we have this wonderful resource, if you will. As always, here, let me open up my window to show y'all. We have this great thing called Kube Academy. If you haven't been there, let me show you. It'd be good if I actually shared the screen. No, you don't want to see that. Oh, I remember what I did here. Let's see, I was sharing on the laptop. Let me fix this up. This is not actually the right screen, so to speak. Is that one? Nope, that's not it. There we go. Now you see the right one. Boy, I'm never sure where to start, but I don't want to do a quiz. Those are two things I don't want to do. But if you go to kube.academy, you can see like all these great things that we have for educating yourself on Kubernetes. You know, if I spent more time here, I would probably be a lot more wiser and better at my job. So I should probably think of that. But what I wanted to look at today, I will show you. I thought we'd watch this together. I have bookmarked, you know, I like to keep track of what my ideas for the show here are. And I have bookmarked here, which I'll put down here in the chat, what looks like a very interesting, basically how to build platforms with Kubernetes, things to think through. As you know, Kubernetes is a platform for building platforms. So, you know, if you wanted to build a platform, I think this course covers a lot of it. Now, of course, we here at VMware sell Kubernetes distributions and platforms, so you don't have to do a lot of that building. You got to figure out if it's worth your time to build, own, and manage your own platform. If you'd like to be a software vendor, that is. Some people like doing that and some don't. Who knows? I don't want to tell you how to live your life, except if you're interested in buying some stuff from us. Then I'll try to tell you how to live your life. But you can see there's all sorts of things going through here. And, you know, the one that got me interested was exposing storage primitives. So let's watch that one together. Now, I've created an account at Kube Academy and logged in and all that stuff. You would have to do that, I think, to use this free resource. So let's start with the fun music, and then we'll watch it together, and I'll stop and take some notes, things like that. Notes as we watch, as I will try to learn this well. Why do I want to go over this? Because like people are always like, oh, you got to have stateless applications and storage is difficult in Kubernetes. And it's like, you know, whatever. But basically, if you don't have storage for an application, you don't really have much, especially in normal organizations that are large, enterprises, if you will. So let's take a watch. Let me make sure that the audio is working. Let's take a watch. Let me make sure. Hello,
Kube Academy. My name is Sean McGinnis, a staff open source engineer at VMware. In this lesson, we cover some of the capabilities you will want to provide in your Kubernetes-based platform that can enable stateful and persistent storage for your workloads.
See, that's what you would want with an application. You want some stateful and persistent storage. So let's see what we got here. Now I'm skipping over the concepts thing. I'm going to assume some basic understanding, the same level of basicness that I have, which is to say, kind of shaky and shoddy. But let's go on.
There are really good patterns to follow to avoid needing statefulness in applications. But the reality for many workloads is that at some point, your application will need to write out persistent data somewhere to perform its operations. By default, pods have access to local ephemeral storage within the container. As pods are created, storage goes with it. But as soon as the pod is restarted for any reason, this data is lost forever. There's no long-term guarantee about the durability of this storage, and your applications cannot expect any performance SLAs. When designing a deployment, it's easy to use something like HostPath that'll...
In other words, just useful for temporary things. You know, the default storage that comes in Kubernetes, the way it's set up, is really just used for temporary storage and kind of doing things locally, but you can't depend on it, which, you know, is sort of a bummer if you're making applications. So hopefully there's another way of doing it.
You to declare somewhere your application can write data to on the node. But this has some gotchas as well. If the pod restarts and is rescheduled to another host, or the original host is down either temporarily or permanently, Any data written to the host path is lost without extra precautions outside of Kubernetes to protect it.
See, now here's what I'm hoping, right? Like I'm hoping that I'm not a major part of the whole Kubernetes community, but maybe they were like, hey, people want to have persistent storage, so we should make that easy. That would be cool if that was just a thing that they had in there. But we'll see what if it is just as easy as doing it, right? Like, it'd be great. I guess you would probably open a YAML file, and if you put in the YAML file, hey, make that thing persistent, and you just said that, put it in quotes probably, hey, make it persistent, and then it was. But things are often not that easy. But if you're building a platform, hopefully out of Kubernetes, hopefully you can enable that. So let's see what happens next.
Kubernetes addresses the need for persistent storage with a convenient way to declare what your application needs. Persistent volumes are a way to have storage location independent of your pod that has its own lifecycle. As a Kubernetes system administrator, this allows you to control what and how storage is made available, while hiding those implementation details from users deploying applications on your platform. Platform users don't need to worry about how storage is configured or where it is coming from, trusting that the administrators have set things up the way it needs to be and will handle managing whatever storage administration is required. Platform users don't need to worry about how the storage is configured or where it is coming from, trusting that the administrators have set things up in a way that it needs to be and will handle managing whatever storage administration is required. For someone deploying an application, they can just use a persistent volume claim to declare what their application needs to be deployed. So just like how you can declare what CPU and memory resources are needed, you can also declare how much space is needed and how it is accessed. This certainly makes it easier for users and allows them to declare their application needs in a consistent way, but it can put up more burden on you as the administrator. There's no getting around the need to manage whatever storage type is used, but it's on the administrator to create the persistent volumes ahead of time to provide the space for the persistent volume claims to use. And another administrative concern is that you may have access to multiple persistent storage sources, and you want to provide access to your users based on different storage characteristics that they actually need. For example, you may have faster storage that is ideal for workloads that need high performance, but this is too expensive to use for everyone if they don't have all those performance requirements. For everyone else, you may have lower performance storage that is cheaper that would meet most needs. So now as an administrator, you need to be concerned about exposing storage to your users in the most efficient and cost-effective way. As the administrator, you would really like the end users to be able to just...
Now that's a good point, right? If you, what survey was I looking at? You know, I think, let's see, where is the O'Reilly Cloud Adoption? I just wrote a little blog post for our blog covering this. But let's look at, you know, when it comes to, where's the write-up? There we go. Then you don't have to lead gen yourself too much, but you know, whatever. But let's go. These are a great report. When we publish the blog post, I'll have to go over it in more detail. But let's look at, I think, here we go. Oh man, I don't really like these stacked charts at all. So, because it's very annoying to be like, I don't like stacked charts like this. But you can see that when it comes to concerns that people have with cloud, stuff they're worried about, that basically like cost is, if I know how to read a stack chart correctly, basically cost is the first concern, the primary concern that people have, or at least respondents to the survey, 30% of them said that it was a concern for them. I think they could choose more than one, but cost is always something that you need to pay attention to, which we don't always talk about as much as we probably should in like the cloud native Kubernetes kind of world. We kind of do, but because we're usually technologists and things like that, we're typically just interested in the cool part of it. And it comes down to the operations people who are interested in cost, right? Because they're usually the ones who are on the hook to pay for it. So if you're a developer, cost isn't always a major concern, but if you're an operations person, it is. So there you go. You want to have different types of storage so that you can really control cost over things, and also the performance characteristics.
Declare their application requirements just like other resource needs. This is exactly where storage classes come into play. With storage classes, you can configure multiple storage properties and how they can be provisioned. This eliminates the need for you to predefine persistent volumes for your users to claim. Instead, you can define storage classes with different properties and control where and how they are created by configuring provisioners. The internal storage details.
Oh boy. We're like 3 to 4 levels deep on abstraction layers here, which is fine. So you got a persistent volume, which is generic storage. Then you have a storage class, which specifies the characteristics of that storage. And then I'm guessing you're gonna have an actual, what are the physical disks or SSDs or storage that the storage class maps to, which is all fine. Having all these layers of abstraction is both what makes something great for building a platform, because it's very extensible and generic. It's building blocks. But it's also a large part of why, if you don't build a platform out of something like Kubernetes, it gets very complex and confusing. Because again, remember, the goal of Kubernetes is to provide a toolbox, a stack, a warehouse of stuff you could do, and how to run it, of building a platform that you run your software on. It's not intended to necessarily be straight out of the box, does everything you need. You got to go and configure and set it up, because it's a toolbox, a framework for things, not the actual end product. So let's see how many more layers we go into.
Can be safely abstracted behind the classes. The descriptive names of each of these classes can be published for your end users to choose from. Now, when your users declare their application needs,
maybe storage class was the end of the bottom of the layers, because you see the provisioner down here, but we'll see.
They can just pick which class of storage they need for their app requirements. Underneath, the provisioner is defined for the chosen class.
Now, see, this is something I've been going on for a month that I need to sort out. Now, I should ask someone about this. Maybe if you have some leads, dear viewers, that would be great. But, people are always talking about how Kubernetes has a bunch of APIs and things like that. But I think what they mean when they say API is a YAML file that you then pass to kubeapply. I don't think they mean an API in the sense of like a procedural thing like whatever, XML RPC, is that still a thing? Or actually like connecting to a process and telling that process to do something. I mean, of course not, because Kubernetes is all declarative instead of imperative. Is that right? But I think it's probably worth, if only for me, but it's probably worth the time in any Kubernetes discussion to kind of specify that an API actually means a file, a YAML file that you're defining. It's a configuration, which to my mind, I don't know if I would call that an API. That's a lot different than my notion of what an API is, but I get the idea of what's going on there. I don't know, maybe I'm wrong. Only time will tell.
Can allocate the necessary storage on demand and expose that to the pod wherever it's deployed. There are many different provisioners available, from the various cloud provider storage offerings, VMware vSphere storage, Ceph, and many more on-prem storage systems. You can see the Kubernetes documentation for a growing list of various storage devices that have integrated with Kubernetes. Okay, let's take a quick walkthrough of what dynamic storage provisioning would look like in practice. So in this case, I'm going to be creating 2 storage classes. One called...
Hold on, let's back up a little bit. I think we use Venmo to host this stuff, right? Doesn't this look like their interface? So here we go. So this is the fun stuff. So yes, you
can see the Kubernetes documentation for a growing list.
So you've got persistent volumes. Now I didn't quite understand what a volume claim is. Let's go back and what is a persistent volume claim? Oh, I guess that is a persistent volume is the idea of a volume, and a claim is I want to use it. Is that right? Let's host path. Okay, let's see.
As a Kubernetes system administrator, this allows you to control what and how storage is made available, while hiding those implementation details from users deploying applications on your platform. Platform users don't need to worry about how storage is configured or where it is coming from, trusting that the administrators have set things up the way it needs to be and will handle managing whatever storage administration is required. Platform users don't need to worry about how the storage is configured or where it is coming from, trusting that the administrators have set things up in a way that it needs to be and will handle managing whatever storage administration is required. For someone deploying an application, they can just use a persistent volume claim to declare what their application needs to be deployed.
All right, I'm still a little unclear if persistent volume is a concept or a thing, so to speak. But it looks like basically, I mean, I guess it's a concept, and in some YAML file, you'd have to define that the persistent volume has this name, And so a claim, again, I think this is where the API thing confusingly for me comes into play, is a persistent volume claim is a API call, which is to say writing some stuff in a YAML file. But it's an API call to say, I would like this to be configured for me, which is cool. So that's like a way of saying the type of storage that you want. And then you go down to storage classes, which basically defines the types of storage that you have. And in theory, let's see, this isn't quite saying the type that you want, but that's okay. It's simplified for a demo. And then at the moment, so you got your storage classes, and here you've got a named profile of it, and we're going on, performance. And then we got all sorts of, what do we got here? We got the VMware one, got all these, OpenStack. Yep. So we got all sorts of, those are just some highlights. You could look at more. All right, let's go back up here and see what we're doing.
In this case, the Azure Disk Provisioner. Now, there are all other properties that you can define for a storage class, but these are some of the just very basics just to get a default storage provisioning basics just to get done. If we take a look at the fast definition, same thing here, storage class. I'm giving it the name fast and using the Azure Disk.
All right, let's look at this because this is a full one, unlike a demo one. So, yep, see? An API call, as we would say in the old world. So, metadata, so we name it fast, the provisioner. So this is a class definition. See, that's more what I would call like a YAML file, is a definition, not an API call, but whatever. You know, these kids today, I don't want to be the uncool old person. I need to learn their lingo. So let's see, we're loading this up. This is a storage class. So this is the Azure one. All right. So we haven't done the claims yet. We're just looking at the admin to the point of this Kube Academy session, learning how to build a platform. So this is not really something that application developers would use. This is what your platform developers, your platform team, your SRE people, you might even call them DevOps engineers, although that term is up in the air at the moment as far as what it means, but let's go on. So then that's your so-called slow, more affordable storage. And then here we have the faster storage class. So we're defining this, and volume binding, I don't know what, I guess, yeah, parameters, all right. So let's just keep going.
The volume binding mode is set to wait for first consumer. So the volume won't actually be created until there actually is someone that tries to bind that volume. And in this case, I'm passing in some other parameters. This varies depending on the provisioner that you're using. But in this case, I'm using some premium storage on Azure, and that'll give me a little better performance. So here I will just create the two storage classes by applying these definitions.
There we go. The API call, so to speak. Or because it's, is it imperative? I get it mixed up. Because it's declarative. You're not calling an API. You're just expressing your desire that the state of the world should match what is in a YAML file.
And that's pretty quick. Now, if we take a look at storage classes, we'll see we have the name fast that has those different settings where we're retaining the volume and waiting for first consumer, and slow with the defaults of delete and immediate creation. Now, if we move over from an end user's perspective, here I have database backend that I'm creating and a web frontend. So if we take a look at the web frontend, first, I'm creating a persistent volume claim. So we still need to define a claim stating what we need from storage.
Well, we're gonna have to pause this one. What's going on in here? So another API call. I should stop commenting on that. So here we go. Web claim. So we're making a claim. We're claiming the storage. Like we're going out into the Old West and claiming a patch of land. Of the states, that is. So read write once. I don't know what that means, but that's fine. Storage class slow, storage 5GI. Sounds cool. And then here's the pods. This is our web front end. We'll put an Nginx in there. Okay. So we're basically, once again, declaring what it is we want, right? And kind of defining the infrastructure.
In this case, I'm giving it the name web claim.
Oh, then let me try to guess here. So we've created something called web claim, right? And then we are going to go down to, there's a mount. So at some point, we're going to have a map, so the same name. This stuff drives me crazy about YAML, but that's fine. It's gonna be mounted here. So whatever application you're using is gonna know that this is where it can go in the file system to get its storage. And then we call it volume. In demos, it'd be nice if people stayed away from these generic names. Like there should be very specific names for things. The worst is when you get the bar baz food stuff, and that's just like, or ABC, it makes no sense, but like, volume is a little like too generic. It should be something like, web claim volume or whatever, but that's fine.
There's different access modes. And the interesting part here, as far as dynamic storage provisioning, is this storage class name, where I'm saying I want to use the slow storage class. And I tell it that I would like a 5 gig volume. So then below, in this case, I'm just creating a pod, calling it web front end.
Mm-hmm.
And I'm using Nginx, and I tell it that I would like a volume mounted in the path mount Azure, and referencing a volume named volume. So if we look under the volume section, I have a volume named volume, and I'm telling it to use the persistent volume claim.
There we go. Look at that. Yeah. So this is a common pattern, right? So we are, again, not imperatively doing that. We are expressing our desire that this should exist in the world. And basically we've created it's called a named storage service, to use my own words. And then we go down here and we say in my pod, we want to have this mount available to any application running. And what is the type of mount, which we have called volume? What is this? See, I would name it what it's going to be used for. I would call it something like, like, I don't know what app is in here. Let's just say it's just let's say it's an app for ATM locations. So we want to have a file that lists all the ATM locations we have. I would call this like, ATM location drive or storage or something. And then it's kind of easier to track the semantics of what's going on here instead of just a generic volume. Or even if it's only Nginx and it's just a front end for things, you could call it like, web server drive or Nginx drive, but whatever.
Web claim to match what was done above. So I can apply this, and you'll see those objects are
another API call that is not an API call.
Created. Now if I take a look at persistent volume claims, you can see our web claim, and it is already bound and references an actual
Great name, by the way. I should have named my daughter that.
Persistent volume. And as we requested, it gave 5 gigs with read write once using the slow storage class. And take a quick look at the persistent volumes. We see that persistent volume referenced from the claim, same information reflecting some of our other settings. And if we take a look at pods, it's creating that pod. Okay, now we see that our web front end pod is running. Let's take a look at that. From here, in the events, we can see this attach volume, attach succeeded. So it was able to successfully attach our volume. And if we take a look up here under the volume section, we'll see our web claim and that there's a volume mounted on Mount Azure. Under the volume section,
hold on,
we'll see our...
I was daydreaming.
In the events, we can see this...
So what do we got here? All right, what are we looking at? So we looked at the pod. Okay, so we're poking around in the pod.
See that our web front end pod is running. Let's take a look at that. From here, in the events, we can see this attach volume, attach succeeded. So it was able to successfully attach our volume. And if we take a look up here under the volume section,
Probably should have had this larger the whole time, but whatever. Okay, so what do we got here? We have a claim. They're set up in the same namespace. All right, well, I don't have a tremendous amount of time, so I'm going to skip over understanding this exact part.
We'll see our web claim, and
I mean, this part is just proving that it exists, right? So let's just assume goodwill and intentions.
There's a volume mounted on Mount Azure. So that's using our default storage. Now we also have the fast storage, and in the case of our database backend, I'm using another persistent volume claim, naming it DB claim, and in this case I'm using fast for the storage class, and again requesting 5 gig. So I'm creating a pod named DB backend, creating a SQL server, again mounting on Mount Azure, and referencing a volume using DB claim that we defined above. So
That's great. It's pretty simple.
Apply this one. Now if we take a look at our persistent volume claims, we should have our 2 volume claims, and take a look at our persistent volumes, and we have our 2 volumes. And formatting is a little off here, but you can see one is using storage class fast and one is using storage class slow. This lesson gave a very quick overview of persistent storage in a Kubernetes environment. We covered some of the persistent storage services that can be configured to enable users of the platform's needs.
Fast forward here a little bit.
Based on your needs and what type of storage related options and how you would configure them for your application.
What do we got here?
Platform.
Now, it's always good to, unlike with a fictional story where you don't want to, well, I don't want to read the reviews and the cliff note, the summary before I actually do it. Whenever you are studying something like this, it's good to see a overview, a lecture, if you will, and then go read the official documentation.
More about dynamic provisioning in the provisioning sections. Thank you for your time. Let's continue on to learn more about the service.
All right. Well, that was pretty good. My conclusion from that is that didn't seem too complex, and storage doesn't seem like a mystery at all. You just have to set it up. So storage is pretty easy to do. Now, I'm sure there's all sorts of wingdings and fling-flangs and things like that when it comes to, securing the storage and things like that. But I think also what you see is that a lot of that is also pushed down away from the developers and even pushed down from the people building that. Because I would assume you inherit a lot, if not all, of the capabilities that you have with the specific type of storage in your storage class. So you kind of have access to a lot of those different functionality. And this is kind of a theory for one of the other benefits of Kubernetes is that, this is like cloud in general, but instead of having to commit to certain types of storage arrays and storage that you're doing on your own, you can kind of pick and choose from whatever's available out there. You can be my definition of multi-cloud, which is using the capabilities from whatever cloud you want or just running apps to whatever cloud. I guess it's more the second one. That's a whole other thing. I'll have that in my newsletter at some point, my overly nuanced definition or how I think about that stuff. Although really, it is kind of both. Like here you could see you can use an Azure disk in a cluster, or you could use your own local disk somewhere, as long as you configure and set that up. Now, the other thing, which I think would be fun to see in the Kubernetes world, is how you do the documentation to tell your developers about all of this. We have something interesting in the Tanzu application platform for APIs. There's actually like a portal you can use to list all the APIs you have and how to use them and things like that, which I think is useful. And having that for all this stuff you've declared in Kubernetes would be very useful as well. So you build a platform and then you have something that kind of auto-generates the site for it. Maybe one day I should look up if that's what the backstage thing does. I don't know. We'll find out. Anyways, we've now completely solved how to do storage in Kubernetes. Not really. But that was kind of fun. I should go through some more of these. Well, as always, this has been Tanzu Talk. If you want to get archives, there's all sorts of videos. If you go to tanzutalk.com and click on the videos link up there. There's also, I've managed to do several audio podcasts. One about how cloud native stuff can help out in smaller government organizations, which is great. There's a big opportunity there. And I just published an interview that I did with someone who's writing a book on cloud application security. It's a really good book I've been reading through. You can, if you buy it now, you can read through the preview as well. But you should go check those out. Those are at tanzutalk.com, or if you search in your podcast listener for that. But with that, we'll see everyone next time. Bye-bye.